Hi, welcome back to part 3 of the binormal vectors. Yes. All right. Now, honestly, we are going to take a pause on the first example I did up here right now, okay? We'll see why in just a few minutes. We're going to go straight to part B. Now, for part B, this should be this is going to be a really easy one. So we already should recognize from previous videos that this right here is going to be a circle. It's not going to be a spiral because my z-coordinate's not changing. So this is just a circle on the xy plane right here. So what we're going to do, we are going to find the binormal vector. Now remember, our binormal vector is the cross product. Our binormal vector is the cross product of our unit tangent vector. Cross that with our unit normal vector. We talked about that in video 1, so take a look at that if you need to. So let's see here. So the first thing we need is, of course, our unit tangent vector. We get that by looking at the derivative, r prime of t, divided by its magnitude, r prime of t. So let's go ahead and calculate that. That's pretty easy to do. Let's see here. If we look at the derivative up top, don't forget this is going to be quotient rule, chain rule. That's terrible of me. I teach calculus some days. So this becomes negative 3 sine 3t, 3 cosine 3t, 0. Now notice, remember, if I'm thinking of r prime of t as my velocity, this is the change of velocity in my x's, this is the change of velocity in my y's, and the 0 has 0 change in the z. So remember, my z's are not changing, so we're just going around in a circle on the xy plane right here. So we can kind of see that. The magnitude, we just square those. That's going to give me 9 sine squared 3t plus 9 cosine squared 3t. Do not leave it like this. That's just going to become, well, we know sine squared plus cosine squared is 1, so we're multiplying that by 9. So we get the square root of 9, or just 3 on the bottom. So my unit tangent vector then would be negative 3 sine 3t cosine 3t 0 over 3. And oh my gosh, I can even go further. Whoops, sorry, because that was a 3 cosine t. There we go. Forgot my 3. We can go even further. We can cancel out the constants in the front. So I can divide everything by 3. So I can write my unit tangent vector as just sine 3t cosine 3t 0. Anytime you can simplify, that's the best. So there's our unit tangent vector. Oops, there we go. Bring the 0 over there so you can see it. Now recall, this is a constant. We like constants today, so we're happy with constant. And next we need to get our unit normal vector. That's n of t. And remember, that is the second derivative of t divided by its magnitude, r prime of t. Our second derivative, remember this is r prime. Our second derivative, don't forget, chain rule, is going to become negative 9 cosine 3t comma, this should become negative 9 sine 3t comma 0 divided by its magnitude, and hopefully we're kind of getting a little bit faster with this. That's just going to be the square root of 9 again. Oh, sorry. That's going to become the square root of 81, right? Because that's going to be 81 cosine squared plus 81 sine squared, which is the square root of 81. And again, those 9s are all going to cancel, and what we're left with is negative cosine 3t, negative sine 3t, 0. So there's our unit tangent, there's our unit normal, and now we have to get our binormal. Remember, because the magnitude of r prime was constant, I can use my shortcut. So remember our shortcut. Let's go review our shortcut real quickly. And just one time, we have the unit tangent, cross that with the unit normal. Remember the unit tangent is r prime of t over its magnitude. Cross that with the second derivative over its magnitude. Because if this is a constant, these just basically can be factored out. So what we're looking at is just the magnitude, is just the shortcut, so that I can just take r prime of t, cross that with r double prime of t, divide that by the magnitude of the cross products of our magnitudes. Or the magnitude of our cross product. Boy, we got that backwards there. There we go. So there's our shortcut. So our rule, first, find that cross product. To do that cross product, I, J, K. Just kidding. Okay, that was fun. So we're going to get sine 3t, cosine 3t, 0, negative cosine 3t, negative sine 3t, 0. And we're going to figure out what this is. So if I cover the i's, oh, look at that. Look what I get. I get 0, 0. So I get 0 i's minus, look at the j's. Cover the j's. I get 0 j's, right? Minus 0 j. Plus, look at the k's. Ah, this is where the k's is. Take a look here. So plus, now I'm going to do here, this becomes negative. Let me make a mistake here. Oh, yeah, I did. Take a look here. See this right, negative right here? I forgot to carry it over here, so it's negative right there. There we go. So that should be a negative sign right there. So that becomes positive sine squared 3t plus, and that's going to become a plus because it's a minus cosine squared, but we're subtracting, so plus cosine squared 3t. Okay. And of course, this is just 1. So therefore, our binormal vector is just 1k. So think about what that means in physics. Remember, we have our tangent vector, we have our unit normal vector. We're going around a circle, right? Where is our force normal? It's going straight up. We can see it's how much that force is going straight up. And if you're going around in a circle, remember, when we looked back at our example with the car, right? If you're going around in a circle, you have the force of the gravity and weight of the car going straight down. If you're going around a circle, that force normal goes straight up. So, in other words, this is 1 unit in the k direction. Right there. Okay, so that's question number 2. Now, I'm actually going to do a 4th video for this one, just to take a look at A. We might not even finish it, okay? Maybe make you guys finish it. I'll see you soon. Bye.